Okay, Assalamualaikum and good day to everyone. So now we continue to the next objective, which is to describe the kinematic of particle that move along in fixed curve path by resolve into normal and tangential axis. Okay, now, so this is 8.4, curvilinear motion in fixed curve. Okay, so now, what is the curvilinear motion? As we have defined in the previous chapter, in the previous topic, so it's referred to a particle that have moved along a curved path. So this is the curved path. So this is the particle moving in a curved path. So the curved path is often described by three dimensions. So the first method, it can be resolved into the rectangular component x, y, z, and then it can cause changes in both in the magnitude and direction of the position, velocity and acceleration vector. So velocity vector is always directed tangent to the path, and then the acceleration vector is tangent to the holograph. So you should be able to sketch now, right? Okay, so here, what is a normal and tangent component? So you may refer to this figure. So this is our curve path. So this is the position. So now, this is the origin. So now we have, first we need to get a tangent. So this is the V. V is always tangent to the curve. So here we have V. So perpendicular to the V is a normal. This is T and this is normal. So that is how we can establish the normal and tangent axis. So here at the normal tangent here, so this is also this origin. So we can call it as a rho. What is the rho? Rho is the radius of curvature. So now this is the new term lah. New term for you to understand how you want to establish the coordinate tangent and normal. Okay. Okay. So now this is how the normal and the center of curvature can be resolved. Alright. So now this is the usual. Okay. So this is for the acceleration. Okay, so now here, take a look here. So now we are in the normal and tangent coordinate. Okay, so here this is the particle. So this particle, so here we already established this is the A tangent. So because of this is V and this is a tangent, and then perpendicular to the tangent is the normal. And then this is the origin. So here, if we have 80 here, so we have the A normal here. So how to determine the magnitude of A? Right. So definitely acceleration is given by the square root A T square plus A n square. So for this case, this is the this is the formula how to determine the acceleration from the A tangent and A normal. Okay. Okay. So this is the first formula, and then the second formula is to determine what is the A normal. So A normal is given by V squared over rho. And then what is the rho? Rho is the center of curvature. So the normal or centripetal component is always directed toward the center of the curvature. So this is the center of curvature. This is the center of curvature, rho. Okay? So this is the second formula. A normal is equal to V squared over rho. So V, you know how to get the V, right? Okay. Alright. So this is the same. This is the same. The magnitude, how to get the magnitude of the acceleration. Okay, and then this one, the tangential component is tangent to the curve and in direction of increasing or decreasing velocity. So we have the relationship here. So if we have A tangent is equal to V. So A tangent is equal to V. A tangent is equal to V. Or we can derive by the instantaneous velocity. So we can have the A tangent ds is equal to V dV, as what I've established before. Okay, so understand? So we have how many equation here? So first, second. Okay, the next. What is the equation if we are not be given the rho? We are not be given the central, the center of curvature. So what is the equation for the center of curvature? Okay, so the center. Okay, so this is the center of curvature. The third equation. Okay, so this is the third equation. So you must remember the third equation. Okay, so this equation, how you can solve this rho if not be given. So must remember, if the radius of curvature is not be given, you need to determine first derivative, dy dx. And then you need to determine the second derivative value for dy square and dx square. Alright, so means that you need to get what is the path equation. Alright, so after you get the path equation, then you can get what is the first derivative and second derivative value. Then you substitute into this equation, then you may determine the radius of curvature. So under this topic, you must remember, under the normal and tangent axis, you must have 3 equations. Understand? Alright, so another thing that you should know is about the let's say here we have a 3-dimensional motion, so you may refer to this figure. So here so now this is the particle, so must remember this is the curved part, so this is the tangent. Okay, V, this is direction. So direction, so this is the V, so there must be the A tangent. And then okay, perpendicular to this, no, okay, this one, perpendicular to this is the normal. So this is tangent, this is normal, and then you gonna have A normal. Okay, so now in between the A normal then and A tangent, we also have the B. What is a B? B is direction of binomial. What is the binomial? This one. There is no motion, there's no velocity or acceleration in the binomial direction. So this is the case when if a particle move along a space curve, normal and tangent axis are defined as before. At any point, tangent axis is tangent to the part and the normal axis points toward the center of curvature. Okay, point towards center of curvature. So the plane containing the end normal axis is called oscillating plane. And then a third axis can be defined called the binomial axis B. So binomial unit, vector UB is directed perpendicular to the oscillating plane, and its sen is defined by the cross product. UB is defined by the UT cross UN. Okay, so but here if we don't have the motion, so we don't have the velocity and acceleration. Okay, so this is the application for the normal and tangent axis. Is that how to analyze the motion of car traveling. So how we can get the acceleration, right? How to get, like let's say if the car speed increasing at known rate and it's travel along a curve, how can we determine the magnitude and total acceleration? So we can solve it by using the normal and tangent. And also if we have the roller coaster here, so how can we determine the velocity and acceleration? So as usual, we can use the normal and tangent axis. Okay, so what is the step for analysis? So for this case, of course, number 1, you need to establish normal and tangent coordinate at the fixed curve. So we must remember that. So the first one, we have the positive tangent towards the motion. That is what you need to sketch first. And then normal axis is directed toward the part of the curvature. Okay, understand? Right, first you need to establish the tangent. the V, and then you need to establish what the N axis to allocate the A normal. So this one tangent to get the A tangent. Okay, number 2, step 2, you can apply any equation, okay, which is related to the equation. Alright. Okay, let's do example 8.6. So here what we have. Refer to this figure. So we have here both travel a circular path, and then R. What is the R? R is given 40 meter at a speed that increase with time v 0.0625 t square meter per second. Determine the magnitude of the both velocity and acceleration at the instant t is equal to 10 seconds. So when you sketch here, so this is the motion, right? So this is the motion. So must remember tangent. Tangent to the motion is D. And then the curvature. This is the center of curvature is N as Z. So here you're going to have AT, and here you're going to have A N. AT, then AN. So what is this? What is the 40? 40 is the radius of curvature. Is given by 40 meter. So the question want to determine the magnitude of both velocity and the acceleration. So what is the V? And then what is the acceleration? So acceleration is given by, here you should have AT squared plus A and squared. Right. So in order to get this, you need to find what is the A normal, right? What is normal? So you must remember A normal is equal to V squared over rho. So rho is given. Okay, so what is the V? So how to determine the V? So here, right. So the question is given the V. So your V is equal to 0.0625 t square. So you can get V from this equation. So this one 80. So definitely also from this equation. Okay, understand? Very simple, right? Okay, so next, now we need to determine what is the V. So here, the velocity vector is given that V is equal to V ut, which is ut is the direction, where the magnitude is given by V is equal to 0.625 t square, and then given by t is 10 seconds. So now, to get the value for V, we just substitute t into this one. So your V is 6.25. So you're going to use this to get this one, to get the A normal, right? So A normal, V squared already determined, and then V is 40. So you can calculate. This is the A normal. This is the A normal. Okay, AN, right? So next you need to get what is the AT. So now AT, you can derive the velocity that given here, 0.0625 t square. So you derive 0.025 t square. So you get AT here. AT is equal to 0.125 t. So now you substitute t is equal to 10 seconds. So you get AT is equal to 1.25 meter per second squared. So this is the AT. So to determine the magnitude of acceleration, substitute into this one. Okay, substitute AT. So A, magnitude A is equal to AT squared plus AN squared. So you can get magnitude for the acceleration is 1.5 meter per second squared. Simple, right? Alright. Okay, next example 8.7. So we have here a roller coaster travel along vertical parabolic path defined by the equation y is equal to 0.0 x square. So this is the part. So this is the part. So at a point B, it has a speed. Okay, so now you have a speed here. Speed means what? Speed means the AT, right? Okay, not the AT, the V. So 25 per meter square. V, right? So which is increasing. Increasing at rate 3 meter per second square. So this is the AT, right? Or the acceleration. Determine the magnitude of the roller acceleration when it is at point B. So this is the point B here. So so now this is the X. So this is the Y. So this is the curved part. So moving here, right? So this is moving here. So this is your T, and where is your curvature? So curvature is here. Okay. So now we are not given the rho. So we need to get the rho, correct? So you need to use the formula of rho. So now your X is here. This is your X. X is equal to 30 meter. So you need to derive this one to get the rho. So you need to put into the equation. Then you need to first derive Y and second derive Y to get the rho here. So now the equation needs to determine the acceleration. So simple. So acceleration, as you know, you need to get what is the AT square plus AN square. So you can determine by this equation. Okay. So the first step, you establish the normal and tangent. So we have done. Okay, the second step, what is the info given here? So the change in the speed of the car 3 meter per second is the tangential component of the total acceleration. So we need to calculate the radius of curvature, yes. And then calculate the normal component of acceleration. Okay, after we get the rho, so you can determine the AN. AN is equal to V square over rho. Yeah, so V is given here. Okay, determine the magnitude of the acceleration. So this is 1. Okay, can you do that? Alright. So now it's given here. First, tangential component of acceleration is the rate of increase of the roller coaster, given that at 3 meter per second square. Okay, now we want to determine the radius of curvature. This is rho. So we need to derive first. So this is the first derivation, 0.01 x squared, 0.01 x squared. So you can get, this is the first one, 0.02 x. Okay, so this is the second. This is the second. This is the one derivative. This is second derivative. So second derivative, you get 0.02. So here, you the first derivative, to get the value, then you can substitute the x. So x is 30 meter. So you substitute 0.02 times 30. So you get 0.6 for the first derivative here. 0.6. And then for the second derivative is 0.02. So you substitute here. So you can get rho is equal to 79.3. So after you get the rho, then you can calculate the A normal. So V square is given 25. Rho is 79.3. So you can get A normal is equal to 0.881 meter per second squared. And then A tangent. A tangent is given. So A normal is equal to square root A tangent squared plus AN squared. So A tangent is 3 squared plus A normal. So our magnitude of acceleration is 8.43 meter per second. Alright? Okay. Okay, so you can answer this quiz. So what is the answer? The magnitude of the normal acceleration is what? So you okay, I will attach this question into the pop quiz. Okay, number 1 and number 2. Okay, you can think through. Alright, so that's all for today. Hope you can achieve the outcome number 4, which is you should be able to determine you should be able to solve the problem by using this method. Okay, the kinematic of particle that move along the fixed curve by part resolved by normal and tangent as is. So you must remember that you're going to have 3 equations. So you must know how to apply this equation in order to solve the problem. Okay, that's all for today. See you for the next lecture. Bye.